Hello, my name is Lane Holman, and this is my teaching demonstration for inquiry-based lessons. To begin our lesson, you will see a whole bunch of solutions of different colors. Now, I will give you a hint here. Each of these vials contains the same compound that is producing this color, and something has been changed that has resulted in all of these different colors. I want you to take about 10 minutes to write down some ideas for things that could have been changed that would result in such a drastic color difference across all of these solutions of the same compound. I'll let you pause to do that. And when you return, we'll talk a little bit about what some of these possibilities in environmental changes could be. So, some changes could be the inclusion of salt. Ions, very often complex to form different color compounds. Maybe those blues come from copper. But then, what would the primary component of our solutions be? That's an integral part of this question. Hmm. Maybe there are certain compounds that the compound inside this would react with. That's a really, really good thought. And it is correct. So, what we have inside these vials is called an anthocyanin. It's a class of chemical compound that is produced by red cabbage. So, this can be extracted from red cabbage by boiling it, and it changes color depending on the environment by reacting with something in the environment. Now, we'll begin with our explore phase of this. So you have three possible options to test with the anthocyanin. The anthocyanin can react with lemon juice, baking soda, or water. Now, I'll give you a hint about each of these things. Lemon juice has a very low pH, while baking soda solutions have a higher pH, and water is perfectly neutral. Now, as you do this and as you explore this, what you should see is that in the acidic solutions, the anthocyanin indicator turns red. In the neutral solutions, the anthocyanin indicator is purple, and in basic solutions, it'll turn blue. Likely, some of the compounds that we saw in the engage section included other chemical compounds that also reacted with the anthocyanins. For example, that bright green color on the end likely came from a basic solution that also contained bleach. Now, as you explore this, my hope is that you are taking down lots of observations about what you see. Are there any gaseous products? How about liquid products? Is lemon acidic or is it basic? How about water and baking soda? Try to write down everything that you possibly notice as you're running these reactions. And then we'll move into the explain phase. So, the main overarching question is why were the solutions at the beginning of class different colors? Now, I want you to use the claim, evidence, reasoning response to this, where your claim is why you believe they were different colors. What in the environment was different? Then give me your evidence. What color would it be if you were to add an acid in? How about if you were to add a base in? And then give me your reasoning. Relate all of these things together. How might the acid or base react with the anthocyanin to produce this new color? Finally, we'll move on to the elaborate stage, where you will select an indicator from the list. Determine what makes the indicator change color. You're going to need to do some research for this. I want you to find out what chemically in the structure of the molecule changes that results in a color change. Then, I want you to predict what the color of a pH 10, a pH 7, and a pH 5 solution is, knowing what you know now. As you're predicting these colors, you'll be asked to give reasoning. So, why do you expect methyl violet to be yellow at a pH of zero point 0? What chemically is happening that results in that color? Now, we will end this activity with an extension. So, my task for you is to find a local water source, whether that is a river or the tap at home or a puddle full of dirt down the road from you. Any water works. Then When you come back into class, you'll bring this water sample with you and we'll test it with the indicator that you selected in the elaborate portion of this activity. By doing so, you will determine what the pH of the water is. Once you have determined the pH of the water, this is where the extension really comes in. I want you to identify the ecological impacts of water quality with an emphasis on pH. Do a little bit of Googling. What kind of environments can fish live in? How about aquatic plants? Is there a certain pH range that would potentially be dangerous? What does the pH that you got from your water sample tell you about the health and quality of that water?